Hello and welcome back for lecture 9. This week we'll be talking about Redux. So in the last couple lectures, we talked about a few things. We talked about APIs, which is the way that you interface with external facing services. We talked about making network requests. So how do you actually access these APIs if they're not on your own computer, maybe out in the cloud somewhere? We talked about promises and async await, which are basically a couple ways to handle asynchronous actions, namely making network requests. We talked about how to transform data after you get it back from an API. It might not be exactly in the shape that you want. And so we talked about a few different strategies by which we could get it from the shape that it's in from the API to exactly what we want in our application. We then talked about some simple authentication, meaning how do you ensure that users are who they say they are, and how do you let them into your app after that. We talked about some HTTP methods and response codes, which are basically a specification that lets you take a response from a network request and know exactly if the request succeeded or if it failed, and if it failed, then why did it fail. And then lastly, last week, we had Charlie Cheever as our guest to talk about Expo components. So our applications, as we move throughout the class, are getting more and more complex, and now we're starting to run into some problems. Our apps thus far have been pretty simple, but we're already starting to see some bugs related to complexity. Namely, maybe we forget to pass a prop, or have some troubles directly managing some state that's possibly deeply nested. With more complicated state, we might be starting to duplicate some information in that state object. Or maybe with that duplicated information, when we update one of the props, maybe we forget to update another prop or a bunch of the other dependent props. Or maybe we have components with a very large number of props that don't necessarily need to have that large number of props. Or maybe we see a prop that's not behaving how we think it should be behaving, and we're not really sure where exactly it's going wrong and where that prop should be being managed. And so this lecture, we're going to take a step back and rethink the architecture by which we've been managing our data. So one company that's run into scaling issues is Facebook. So they found that the MVC architecture is a little bit too complex for their scale. And so those of you who took CS50, we talked about this architecture called Model View Controller. And what exactly is that? So in the model MVC architecture, we have models. We have views. And we have controllers. And so views are basically what a user sees. And the data by which are loaded into the views come from these models. And how does a user interface with these views? Well, they do it through this thing called a controller. And then maybe the controller will then dispatch an action that when a user clicks a button or something, and maybe that goes and updates a model. But also, some views might directly change models. And so you start to have this two-way connection between models and views. And when you're operating at Facebook size, you don't just have one model and one view. Facebook actually has something like 30,000 different React components that they use. And so there are a large number of views here. And with that large number of views, there are also a very large number of models. And maybe this view talks to this model and back and forth, and also talks to that model. And maybe that view talks to this model. And now with all of these connections, you see how it's starting to get very, very complicated. And when you scale up to a size like Facebook, you might start to run into some bugs. And so one thing that happened with Facebook is that the complexity manifested itself into some bugs, and namely a pretty famous one that has to do with unread chat notifications. And so what basically happened was Facebook started to add more and more different views for how you access their chat. And so at first it was a little pop-up box that happened in the bottom, but then they added a separate page for chats, and then they added something in the nav bar that drops down with some chats, and then they started adding other applications that handle chats. And all of a sudden, there's a lot of different places where a chat could be updated, or vice versa. And so they had a big bug where users would log in and would have a notification that says you have an unread message. But that wasn't necessarily always the case. And so this bugged a lot of users, and Facebook had to take a step back and figure out a better way to handle this large complexity that they're starting to have in their application. And so what they did is they re-architected everything into a single direction data flow. And so data only comes in from one direction, and there's only one way to update that data. And how did they do that? Well, if you want to see additional background into this problem, you can watch this YouTube video by Jing Chen, and they talk about exactly what the bug was and why they created this new architecture. And so this new architecture was called Flux. And what is Flux? Well, it's a new application architecture for React that utilizes a unidirectional data flow. What the heck does that mean? Well, views react and changes to some number of stores. And what it stores, it stores the data. And the only thing that can update this data is this thing called a dispatcher. And we'll talk about it a little more in a sec. And how do we trigger this dispatcher? Well, you invoke an action. And what is the way you invoke an action? Well, actions are triggered from views. And so let's draw this picture out. So you have a central store that stores all of your information, or maybe some number of stores. And these stores will store all of the data that you need for that application. And how do you update that store? Well, it's through this thing called a dispatcher. And so this dispatcher will actually send information to these stores, and these stores will update. And that's the only possible way to update these stores. And how do you trigger the dispatcher? Well, it's through this thing called an action. And what happens when you have all this information in your store? You use that store to render a bunch of views. And so maybe this view listens from this store and that store. And maybe a view here listens to all three stores. And the view here only listens to that store. And so we have a large number of arrows here, potentially. But one thing to note is that the arrows all go this direction, which means that there's no bidirectional flow. And so multiple views don't necessarily update, or they can't update multiple stores, which is a good thing because a view can just say, hey, give me the information from here and here, but I'm not going to worry about having to go update those back. What I do is I dispatch an action. And so these views are the ways to trigger an action, and the only ways to trigger an action. And so you see what is looking like a large number of arrows, but you see that they're all going in a singular direction. And so you have this unidirectional data flow. So to repeat myself, the only way to update the information, the data that's stored in an application, is through this thing called a dispatcher. And we don't really control this dispatcher. We only tell the dispatcher to start by dispatching an action. And how do we trigger an action? Well, we interact with the views. And by we, I mean our users. And how do these views know what they should render? Well, they get that information from stores. And as stores are updated, the views are automatically notified that they should re-render. And so there's no arrows that are going back and forth here, so the complexity is an order of magnitude smaller, because the views only care about the information that they're getting from the stores, and they're automatically notified when that information changes. So Flux is a general architecture, and there are actually many implementations. Facebook has written one. And there's also this thing called Redux. So whether or not Redux is actually an implementation of Flux is an opinion that can be argued either way. But what's unarguable is that Redux was inspired by Flux. So Redux is a data management library, and it takes a lot of the paradigms that Flux created and implements them for itself. And so there are three big pillars of Redux. One is that there's a single source of truth for all of the data. So in the Flux architecture, there might be multiple stores, but in Redux, there's just one. one big object that keeps track of all of your application state. The only way that you can update the state is by an action that triggers a recomputation of the state. And so it's very similar to Flux in that the only way that you can update a store is by dispatching an action. And Redux is very similar in that the only way to update the centralized data, so you can think of the store as one big thing in Redux, and the only way to update that is by dispatching an action. And lastly, updates are made using a pure function. And so by pure function, I mean a function that takes in arguments and will always return the same thing for those arguments. So it's fully deterministic, meaning given the same arguments, it will always return the same answer. And also, it doesn't look anywhere else other than those arguments for the computation that it gives. So you're not using things like the current time or anything in the environment to calculate things. It's only a function of the input. And lastly, there are no side effects. So I will only, I take input and I give output, and I don't do anything else. I don't print, I don't change variables outside my scope, nothing like that. And so we have this thing. We have an action, goes to a reducer, which then updates the store. And so to draw that, so if you remember this from Flux, we have actions go through a dispatcher, which updates some number of stores, which then updates some number of views. And in Redux land, we have an action gets dispatched and updates some central store. And that will update any of its views. And those views with user interaction can trigger more actions. And so it's a very similar diagram to Flux, and it's the exact same in that it's a unidirectional flow of data, but the main difference is here, where you have a singular store rather than a potentially large number of stores like in Flux. And if you want to read about Redux and its background, you can go to this URL, which is its docs. So let's do something fun this lecture and actually implement something like Redux ourselves. And so where do we start? Let's go ahead and just create a directory into which we'll start creating these files. So what's first? So there's this thing called a reducer, which is what calculates the next state. And so it takes a previous state, and it takes some information on how it should update, and it goes ahead and applies that update and returns some new state. So some constraints, it should be a pure function. So in other words, the result is deterministic. So given the same input, it'll always give the same output. And it's determined exclusively by those arguments. And there are no side effects. So no logging, no changing variables, no doing anything like that. No changing variables outside of its own scope, that is. It should be immutable. And so we've talked about immutability in previous lectures. So it should always return a new object. So the keys in the object might not change, but the object reference itself should change. And let's actually go ahead and start implementing a reducer. And so we said a reducer takes the previous state and some sort of update and returns some new state. And let's go ahead and implement that. So some function that takes a previous state and an update, and it returns some sort of new state. And so how it calculates that state is completely up to us. And so let's make the simplest reducer possible. Well, the simplest reducer possible would actually be this, where we take the previous state, we take an update, and we just completely ignore the update and return the previous state. But let's actually do something. So rather than just returning the state blindly, let's apply some update. And so let's assume the state is an object, and let's assume the update is also an object. And let's just merge those objects. And so we could do something like this. So this would be a very, very simple reducer. So given a state and an update where they're both objects, just merge those objects. And so take all of the keys in state. So if you don't remember what the syntax is, it's object spread, by which you take all of the key and value pairs of an object and you add them to this new object that we're creating. And then do the same thing with update. Take all of its keys and value pairs and then apply them to the same object. And so if there are any duplicate keys, they'll get overwritten by this second update. And so this is an example of an extremely simple reducer. And so let's actually play with our reducer a little bit. We can do something like, let's start as an empty object. We can do state is now invoke the reducer on the old state, and let's pass in something like foo gets foo. And then now let's update the state again. And so let's pass into our reducer the old states, and maybe bar gets bar. And lastly, let's update the state again, pass it into the reducer, and give it now foo gets baz. And so what do we expect to see back here? So we have state initialized as an empty object. And then first, we invoke it and pass in this object that has a key value pair of foo and foo. And so when we invoke that, we have an empty object here and foo here. And so after line 7, our state is just foo foo. How about line 8? Now we pass foo foo into the reducer and also pass an update called bar bar. And so state is foo foo, updates bar bar, and so we now are ended up with an object with a key of foo and a value of foo, a key of bar and a value of bar. And then lastly, we pass that object into the reducer again, this time with a key value pair of foo and baz. And so what we expect to see out of that is an object with a key of foo, value of baz, and a key of bar with a value of bar. So let's go ahead and run this. But first, since object spread is not yet supported by Node, let's just replace it with something like a helper function called merge, where it'll take a bunch of arguments, some number of arguments. Let's actually just do prev and next. And it will do this thing called object.assign, which is the way that we used to merge objects before this object spread became a syntax. And so let's just assign a new object, the key value pairs of previous, and then the key value pairs of next. And then rather than doing this manually here, let's just merge state and update. So let's run this and see what we get. I guess nothing will happen when we run that, so let's just console log the state at the end. And so we get what we expected. So we expected to get this thing with foo baz and bar bar, and that's exactly what we got. And so to recap, all a reducer is something that takes some previous state and something that we want to update it with, and then returns a new state. So in our particular reducer, we chose to just merge the update into state, but what happens here doesn't matter, as long as it's returning a new state object. And so like I alluded to earlier, we can make our reducer even simpler by just doing this. So if we did this, and ran it, we just get an empty object, which is as expected, because all we're doing is we're just passing the old state back. We're completely ignoring the update and passing an old state. So this is a completely valid reducer. It just happened to be that it doesn't do anything. And so instead, we made it do something by merging these objects. Cool. So let's make our Redux model a little bit more advanced. So what's responsible for invoking the reducer? and how do we actually manage the state? Because currently, it's not very good that the way that we're managing the state is just this state object that we're mutating. Why not try to wrap this up in something self-contained, like a class? And that's exactly what Redux does with this concept of a store. So what is a store? So as we talked about earlier, a store is responsible for maintaining some sort of state. And that's really, it does a bunch of other stuff, but at its core, it's just responsible for remembering what the state is. The way that you access that state is through this accessor method called getState. And so you can invoke this method called getState, and it'll return the current state. And how do you update that state? Well, as we talked about earlier, the only way to do it is by using this thing called dispatch, by dispatching an action to update the state. And lastly, you can add listeners that get invoked when the state changes. And so it wouldn't be super great of a reactive model if the store just updated itself and didn't tell anybody. Because the whole point of React is that the UI will react to updates in the application state. And so what Redux does is when the application state gets updated, it'll run some callbacks. But let's not include that in our implementation for now. So currently, we have this very simple reducer. And now let's turn it into a store. And so what does a store need? Well, it should maintain the state within itself. It should expose some sort of getter method called getState. And it should expose this method called dispatch, which is the way that you update these actions. And so let's start to do that. And so let's create this class called store. And how do you create a store? Well, let's just say you pass it maybe a reducer. So how does a store know how to update itself? And you also pass it maybe some initial state. And what should it do in the constructor? Well, it should remember these things. And so maybe we'll say this.reducer is that reducer that you passed it. And maybe the initial state, or the state, is that initial state. Cool, so now we have a store. It's kind of useless because all it does is create this class instance, and you can't actually interface with it at all. And so let's start to add these methods by which you can interface with it. So first we said you should be able to get the state by invoking this thing called getState. And so let's create this method called getState, which is pretty simple. All it does is return this.state. And so now we're starting to make our simple store. We can test it a little bit. Let's just pass it our simple reducer and initial state of empty, and then let's see what the initial state is. And so we can do store dot get the state. So if we run that, we just get an empty object back, which is as expected. All store is currently is a constructor that takes the reducer and initial state, initializes the state to the initial state, and then we have no way of updating the state. And so when we call this.state, it just returns an empty object. And if we had instead passed it some arbitrary object like foo, and then ran it, we'll get that same object back. Cool, so not very useful yet. And so let's start to add some features to it. So first, and most importantly, we should have some sort of way to update that state. And the way that we do this in Redux is by dispatching an action, or by just invoking this method called dispatch with some way of updating. And so the way that we've been doing this thus far is by just passing an object that we want merged into the state. And so let's do that. So let's have this thing called dispatch. We pass it what? We pass it some sort of update. And what does it do? Well, it should update the current state to be what? We want to run this reducer function. And which reducer function? Well, whichever one that we passed in the original constructor and stored as this.reducer. So let's invoke that with the current state. And then any update that we want to pass it. And that's pretty much it. And so now down here, rather than having to handle this ourselves, and by this I mean replacing the old state with the reducer with the value after passing it through the reducer, that's now abstracted away from us using this thing called a store. And so now we can just do store.dispatch this object. And the same goes to here. And so now we're doing things a little bit differently. So rather than creating the state ourselves and manually going through and replacing the state with the output of the reducer and passing in the old state, now that's handled for us by this thing called a store. And how is it handled for us? Well, the store is actually storing the state as part of its class. And so the state gets initialized to some initial state. And every time we dispatch an action or dispatch an update, it handles that for us. It remembers what the reducer is. It knows how it should update its own state by just doing this.state equals the old state, applying the update through the reducer. But we don't care about that. We don't need to know the implementation details. We don't really care. All we care is that we just pass this store.dispatch function some update that we want to apply, and it goes ahead and does the rest of it. We don't even care that state is stored as an object. That's all just abstracted away. All that we care about is we update the state by passing this something into dispatch, and we get the state back by invoking this thing called getState. We don't care that the state is just stored on the constructor. For all we know, maybe it's a tree or maybe it's some weird data structure for performance. It doesn't matter. All that we care about is the API for this store, and this API is just getting the state and dispatching state updates. And so let's make sure it works. So we create a new store down here by saying, give me a new store. I'm going to pass it the reducer function that we defined up here. So let's actually just move this down. And maybe this as well. So now let's just not care about the implementation details of store. All that we care about is we define this thing called merge, which merges objects. We define a reducer, which takes some state and some update and applies that update by merging it in. And then we create a new store with that reducer and some initial value called foo-foo. And that's, for now, that's actually just not passing initial value at all. And let's see what happens. And so we dispatch a few updates, and then now let's log some initial, or the state after those dispatches. And so we get back what we wanted. We get back foo baz bar bar, which is the same thing as up here. And what's the main difference? Well, the main difference is that in reducer, we had to handle the updates ourselves. We had to handle passing into reducer the old state and the new updates. And in this new file called store, we no longer care about those things. We just care that we have a new store and we're passing in a reducer, and we're just dispatching some additional changes. Cool. And so this is not really super helpful for us right now. All it does is merge some objects. But let's actually modify this such that it will help us. And so in previous weeks, what we've been working on is this contacts app. And so I changed a few things from last week, or a couple weeks ago to this week, namely that the login screen is gone and the asynchronous request for fetching the contacts is gone. And so I just reverted the app to where it was before we had asynchronous actions. And so what do we care about in this simple application? Well, we care about the contacts, obviously. We care about maybe adding new contacts by using this add button in the top. And we kind of care about the user. And so before we had this login page where a user would log in, and presumably we should be storing some sort of token or store the fact that the user's logged in. And so we need to care about the contacts, and we need to care about some concept of having a user-user app so we can tell if they're logged in or not. And so let's use what we've implemented in Redux thus far to actually keep track of that information in Redux rather than having to do it ourselves scattered throughout our app. So currently our store takes a reducer in an initial state. It stores those things. It gives us this thing called getState, which returns our state, and gives us a method called dispatch, which applies any updates that we pass it to our state. And so we don't have to change anything there for the context of our contacts app, though we do have to change this reducer. So presumably, if we want to update, maybe we want to add a contact. The way that we would do that would be appending that to an array. And so there's not really a convenient way to do this with our current reducer, since it's just merging objects. So let's actually implement a reducer that will. So say let's call it the contacts reducer. And the contacts reducer, or contact reducer, takes state, and presumably the state is all the old contacts, and it, rather than passing an update, let's just pass it a new contact. And what should this do? So state, presumably, is just a list of the old contacts. And so let's just spread those old contacts, and then add a new contact at the end. And there's our reducer for our contacts. How about for our user? So maybe we should have, how should we keep track of our user? Or more importantly, what is important to know about our user? Maybe something about their username, maybe whether they're logged in or not, maybe some other keys which have values. And so what's the way that we generally store key value pairs in JavaScript? It's usually just a simple array, or I mean a simple object. So let's have this thing called a user reducer, which takes an old state and maybe an update again. And how are we going to handle this? Well, we'll just apply that update to the state. So it's basically the same as our reducer from before. We'll just merge into the old state that update. Cool. So now we have two separate reducers. One handles any updates for contacts. One handles any updates for for a user. And so how are we going to apply that for our store as implemented? Because the store right now only takes a single reducer. It doesn't expect like a reducer for contacts, a reducer for users, a reducer for metadata, a reducer for any other stuff that we want to store. It only expects one. And so we actually have to combine our reducers into just a singular reducer. And so if you remember when we were talking about the pillars of Redux, everything's stored in one singular store, so one big object. But right now we have two separate things that track our application state, one for contacts and one for users. And so how might we go about combining those reducers such that we have just one reducer, one source of truth for our app? Well, the reducer is going to just take a state and some update, just like all of our other reducers. And it's going to have to return some new state. And so we have to somehow tell, via this update, what we should be changing. So we're starting to run into a little bit of trouble here. In our last iteration, we were just passing an object to this dispatch. So this object just gets blindly merged into our state in our store. But now our store is a little bit complicated. As soon as we're hitting a real world use case, now we have multiple different keys in our store. And it's non-trivial how we're going to know exactly what we should update. If we just pass something like foo into our new store, how do we know whether that foo is an update for user or foo is a new contact? We're starting to run into the limitations of how we've implemented our current reducer. And so how does Redux actually solve this? Well, through these things called actions. So an action is basically just a piece of data that contains all of the information required to make a state update. And so in our previous store implementation, this is true about our current update. Everything that we needed to update our state is passed as an argument to dispatch. So this could be considered an action because it has everything that we need to update our state appropriately. But now we're starting to hit a limitation when we have a more complex store like this. We can't just pass an object like foo because there's no longer enough information to make that full state update. And so how are we going to do that? Well, generally, actions are objects with the type key. That didn't necessarily have to be true in our naive implementation of store. But now it makes more sense to have an object because we need more key value pairs. Usually, this object has a key called type. Or in other words, what are we doing here? Like, what update are we making? What should we be updating? And so there actually is a loose spec for what is considered an action in Flux. And so let's go ahead and open that up. And we see here a general guideline to this thing called a standard action, or an action that we should be using universally for all of our Flux or Redux applications. And so the motivation behind that is that it's a lot easier to work with actions if we can make certain assumptions about how they're shaped. Because it wouldn't really make sense if in one application we have our actions as objects, and maybe in a separate application we have arrays, in a separate application it's a number, and maybe in another application it's a string. And so as we scale up, we want to have some sort of uniformity across our applications. And so no matter what application we go to maintain, we know, hey, our application actions should all look the same. They should have some sort of key that tells me the type of update that we're doing here. And so the goal of these actions is that they should be human-friendly. So Flux standard actions should be easy to read, easy to write. They should be useful. Presumably, we're not just creating these arbitrary things for the sake of it. We want them to actually have a use case, to be useful for our application. And lastly, we want them to be simple. There's no reason to add additional complexity when we don't need to. And so a basic action might look like this. So we have a type that designates what exactly should this action be doing. We have a payload, or in other words, like, OK, I know I should be updating this. What should I actually update it with? And so generally, actions are objects with a type key. And maybe they have other things like an error property, payload, or meta. And for our particular implementation, we'll be creating objects with a type and a payload. And so let's go ahead and do that now. All right, so now we know that when we pass in this argument to dispatch, we need to include a little bit more information. It's not enough just to have an object with foo. So let's actually pass a more complex object where the payload ends up being foo, but let's pass in a type so that we know exactly what we should be doing here. And maybe the type is something like update the user. And maybe down here, we do the same thing. we want to update that user with the payload of that bar bar. And the same thing down here. So now it looks a little bit more complicated. Our actions are no longer a simple object. Now they're a nested object where they have a type that is letting us know that we should be updating the user. And it has a payload, which is just letting us know how we should be updating that user. And there's a syntax error here. And so now let's actually look for that type in our reducer. And so now, rather than passing a state and an update to a user, now we're passing a state and an action. And so now we know, now we have some sort of signal about what part of the state we should be updating. And so let's do if action.type is this thing called update user. What should we do here? Well, we know how we want to exactly how we want to update the user. It's dictated by this user reducer. And we know how we want to update the contact. We don't. And so let's actually return here an object that maintains the old shape. So the old state is intact. And now we want to update the user key. And the user key, how do we update it? Well, we pass into the user reducer. And what do we pass into the user reducer? So right now, the user reducer expects a state and update, and it's going to merge the update into the old state. And so what state are we passing into user reducer here? Is it the state here? Not really, right? Because the state here is responding to what state? It's responding to the entire application state. That includes all of the contacts that we have and the user. And the user reducer really doesn't care about any contacts. It only cares about the user itself. And so rather than passing the entire application state there, we only care about the user state. And so we can just do state.user here. And how do you want to update it? Well, it's just the actions payload. And then if the action type isn't update user, just return the old state. So there's going to be invalid syntax here. So let's just use our merge helper function here, where we're merging this new object into state. So it's basically the same thing that we had written before, just in different syntax. So can we all follow what happened here? So we create a store, and we pass in a reducer. What is the reducer? Well, the reducer, it takes a state and it takes an action. And how does it, what's the logic behind the way that we update the state? Well, if the action has a type called update user, we're going to update the user. And we don't care about any other types. If it passes any other type, then we're just going to return the state as is. But what exactly happens when we pass in something where the type is update user? Well, we call that user reducer with the payload. What is the payload? Well, it's just any update that we want to do. Why are we calling it payload? Well, that's just the convention as dictated by Flux standard action. And so what happens in this user reducer? Well, we pass it the old state of the user, and we pass it the update that we want to make. And we don't really care what happens there. It just happens to be the case that it merges. And so what do we expect to happen after we dispatch these three actions? We update the user with foo, we update the user with bar, we update the user again with foo baz, and we expect to see exactly what we saw before. That is an object with a foo, with a key foo with a value baz, and a key bar with a value bar. Is that what we actually get back when we call store.getState? I don't think that's going to be the case. Because there's a syntax error. This error here is because state right now is undefined, and so there's no such thing as state.user. And so we should probably pass in some sort of default user or default application state. And so let's just say the default state is, let's create a const called default state. And let's say the user is just an empty object, and the contacts are an empty array. And let's pass that in when we create our new store. So now we pass in some default states. So when we do state.user, we're not getting an error there. And what do we get back? We don't get back what we were getting back earlier. And what we were getting back earlier was just this, an object with a couple key values where it's foo baz and bar bar. Now we're getting back this thing. We see that object within our state, but that's not our entire state. That object is contained within a part of our state called user. There's also a separate part of our state called contacts, which is an empty array, which makes sense when you think about what we just did. Our application is no longer just a single object. It's now an object that looks like this. We have a key that corresponds to our user information, and we have a key that corresponds to all of the contacts that we have. And so when we're dispatching actions that update the user, they're updating the user, but there's still a whole separate part of our application state that corresponds to those contacts. And so now let's strengthen our store by allowing us to add contacts. How might we want to do that? Maybe we should add a new type. So remember, at the core of Redux is the reducer, which handles the logic between receiving an action and updating the state of our application. And so in our reducer here, we're going to add more logic for when we want to add a contact. And how do we know when we're trying to add a contact? Well, it's dictated by the type of action that we're receiving. So if we get a new action type, and let's call this update contact. Now we want to do something different. Now we don't really care about any update with the user. Now we only care about updating our contacts. And so what might we want to do? Well, let's return a new state. And what does that new state look like? Well, let's update the old state. So merge into the old state this new thing where contacts are updated. And so how are we going to update contacts? What logic dictates how we want to update our contact? We could just do give me the old contacts and add a new contact. And what is the new contact? Action.payload. But this logic is already written somewhere in our app. We already declared this thing called a contact reducer, which does this exact thing. What it does is it expects the state of the old contacts and a new contact. And so we abstracted that information away into this thing called the contact reducer, which expects the old state of contacts. And so we don't want to pass just the entire application state. We only care about the contacts portion of it. And then we pass the payload. So very similar to what we did up here. Up here, when we receive an action called update our user, we go ahead and invoke the user reducer on that user. And when we receive an action to update the contact, now we just do the same thing but for the contacts instead. So now let's test this out. So now let's call store.dispatch this thing with a type of update contact and a payload of name, my name, and a number of some arbitrary string. So now we just sent a separate action. And so now, if you notice, this action has the same shape as the action up here. It's a type and a payload. Now the type is the update contact, and the payload, rather than being the update for a user, is actually the contact itself. And then our reducer knows exactly what to do with all of these things. And so now let's just run this and see what happens. So now our state got updated. So our user still has the information that we expect the user to have. But now we have some contacts. Now it's an array that includes me and my phone number. Don't call it because it's not actually my phone number. And so what happens when we try to add a separate user? Maybe our contact has 2 friends of the exact same name and the same phone number. So now our application has 2 contacts in the contacts, and they just happen to be the same people because I cut and paste. Cool, so now we have some sort of store that's maintaining all of our application information. But admittedly, it's not super clean. So let's clean it up a little bit. So right now we have our action types hard-coded. So we can keep them hard-coded, but let's actually create a variable for our actions. That way we can easily keep track of our available actions. So let's just create this thing called update user and call it update user. And same thing, let's create a const for our action called update contact. And now, rather than hard coding this string here, we can use that constant. And same here. And then same here. So what this does is it protects us against typos. So say I had accidentally typed this in as update users plural. Now it's never going to match. And it might be difficult when we're trying to debug, like, hey, what's going wrong? I'm passing this action called update user, and it's not updating our user. Why? Because we're actually looking for an action type called update users plural. And so to save us from that, we just create a constant called update user. And the way that we enforce that our action types are the same is by using JavaScript itself. If we made a typo here called update users, what's going to happen? We get an error because this constant called update users is not defined. And so by storing our actions as constants, we can ensure that we don't have any weird bugs due to typos. So let's actually move this to the top of the file. That way we can use it in our reducers. And we'll leave a little comment for ourselves, and let's call these action types. Cool, so a little bit cleaner now. We no longer have those hard-coded strings. But now every single time we want to dispatch an action, we have to type that entire action out. And so maybe it might be better to create a function that creates our actions for us. And so let's just create a function called update user. And what does it do? Well, it takes some new user. Let's just update. So it takes some sort of update, and what does it do? Well, it returns a new object, because as we remember, actions are just objects of a certain type And the reason that we create those is because of the standard called flux standard action. And so each of them have a type key. And what is the type every time we want to update the user? Well, it's just going to be update user. And what is the payload here? Well, it depends what we're invoking update user on. And so let's just pass that update in. So now, rather than typing this whole thing out, we can just do update user and pass it the update that we want to make. And what happens here? Well, update user up here gets invoked. We pass it the update that we want to make, and it returns an action. And that action gets passed to dispatch as if we had done this. It's just a little bit cleaner because we don't have to type this whole string out. So now let's do the same thing here. And here. Cool, looking cleaner already. This also looks a little bit gross, so let's create a creator for that as well. And let's call this add contact. And we're going to pass it a new contact. And how is this going to look? Well, just like our other action creator, it's going to return an action. What does an action look like? Well, it has a type attribute. And what type is it? It's going to be update contact. And it's also going to have a payload. And what is the payload here? Well, it's just going to be that new contact. And so now we can do the same thing by calling add contact here. And done here as well. Cool, and now it's looking a lot more readable. So let's just label these as our action creators because they're creating actions. We have our store, our reducer. We have our specific reducers for each key. And then we pass those to our store, and we go ahead and dispatch a few actions. And what actions are we dispatching? Well, it's a lot easier to read now. First, we say, hey, store, go ahead and update the user. And what are we updating it with? Well, we're just passing foo-foo. Go ahead and update the user again with this. Update the user again with this. Now add a contact that looks like this. Add a contact that looks like this. And now all of a sudden, it's very readable. We create a new store. We pass it the reducer in the default state. We dispatch a few actions. And then we go ahead and get the store, get the state, and see what it looks like. And if I didn't make any typos, I made some typos. I never fixed the typo that I made intentionally. So let's fix that. Now we get back exactly what we wanted. Great, so now our homemade simple Redux is looking pretty good. We've implemented most of what is core to Redux. There's a single source of truth for our data. It's in our store. The state can only be updated by actions. So remember, we're dispatching actions. We're dispatching actions down there, and there's really no other way to update. And how are we doing the update ourselves? Well, it's a pure function that takes the old state and some sort of payload or update, or action, I should say, and then goes ahead and does it. Did it do anything else? Did it console log? Did it change any variables outside its scope? Did it use anything outside of the arguments that it was passed? No, it didn't. It was just a pure function of the old state and the updates. And it has this pattern, right? We're sending actions that pass through the reducer, and they updates our store. And so now we've pretty much implemented a simple Redux. There's just one scalability problem with our current Redux. So what happens if when we want to update a user, or maybe we want to update a contact, and maybe in our user reducer, we want to keep track of the number of contacts in our user metadata. We're going to have to change a lot of lines of code in order to do that. And so as we start to add more reducers, start to add more things to our state, in our current implementation of our reducer, it's non-trivial to do that. And so let's actually figure out a better way to do that. Right now, what we're doing is our reducer is taking an action, consuming it, and sending it to one of the smaller reducers that we've created. But there's really no reason that we need to do that. Maybe a better way would be to take an action and pass it to every single reducer. That way, it's up to the smaller reducer to decide, hey, I want to listen to this action, or maybe I'm just going to ignore this action and return my type. So again, why are we doing that? It's because we run into scalability issues if we want multiple actions or multiple of these smaller reducers to react to multiple of the types. So what exactly would that look like? So now, rather than the reducer deciding, our main reducer here deciding which of these reducers to pass to, we should just pass the action to all of them. And so let's actually redefine a reducer down here. So right now, our reducer is taking a state and an action. And maybe what it should be doing is passing back a function where we know we want users, our user, and we know we want our contacts. And what is responsible for keeping track of our user part of our global state? Well, it's the reducer that's specific to the user. And so maybe here we want to invoke the user reducer with some values, and maybe here we want to invoke the contacts reducer with some value. So now it's starting to look a lot simpler. And what values does the user reducer care about? Well, just the part of the state that it cares about. So the state.user. And same thing with the contact reducer. We only care about the part of state that's useful to the contacts reducer. And how does it know what it should do? Well, we just pass it the action. So that there is our new reducer. And so let's now modify our user reducer and contacts reducer to only respond to the action types that they care about. So let's get rid of this. So now we need additional logic here, and maybe some additional logic here. So currently, what cares about update user? Well, it's just the user reducer. So if the action type is update user in the user reducer, let's go ahead and return that update. Otherwise, let's just return the state as it was before. And now we can get rid of all of that logic here. And now let's do a similar thing with the logic for contact reducer. So if the action type is update contact, the contact reducer cares about that, and we should return just this. Else we'll return the basic state. So let me just finish deleting all the code that we don't need. All right, almost there. There's still a couple bugs. So for the contact reducer, what is action? Action.type doesn't exist currently, so we're no longer passing it the new contact. Now we're passing it the action. And so we check the action.type, and new contact no longer exists. Where are we storing the new contact? Well, it's just action.payload. And we do the same thing here. We're no longer just passing the update. We're passing the whole action. And then we can do action.payload. And now we're done. So we can make this a little bit more concise if it's easier to read this way. And now it all fits on one page. So we have our contact reducer, which cares about the state. And when we say state, it's local only to the contacts part of the state. It received actions. And if the action is that it should update the contact, we're returning a new state. And what is the new state? Well, it's the old state. And we append to the end whatever the payload is. And in this case, the action.payload is the new user. Does contact reducer care about update user? No, it doesn't. So if the action.type isn't update contact, we just return whatever the state was before. No big deal. And the same thing is true for user reducer. It's taking a state. What state does it care about? Well, it's only the user part of our application state. It takes an action as well. And if the action type is that it should update the user, then it goes ahead and does that. It returns the old state, and into that we merge the new action.payload. And if the action type isn't update user, just return whatever the user information was before. And one key difference here is that for every single action, every single one of these reducers is called. This reducer is called and passes that action along with the subset of state that each of one of these reducers cares about to them. And then these reducers only do something if the type is something that they care about. Otherwise, they just return the state blindly as was. So now everything's a lot more concise. And now if we wanted to respond to changes in other types in the user reducer, we can. So if we wanted to store something in the user part of the state every single time we add a contact, we can do that now. So maybe if we add a new user, or a new contact, maybe want to store the most recently added contact in the user information. We could do that by doing state. And what are we merging into state? Well, let's just do recently added, or prev contact, is whatever that contact is, so action.payload. And now when we add new contacts, the previous contact is saved in the user. And so now every single reducer can respond to every single action. And let's just make sure it works by adding a contact that wasn't the same as before. As soon as my computer unfreezes. Let's just kill. So let's, again, go into our simple Redux and ensure that we don't pass the same user in again. So we can just sanity check to make sure it's saving the most recent user. We can add David here. And now we can confirm that the previous contact stored in the user is indeed the most recently added contact. And so now we have pretty much a full implementation of Redux. So it's a data management utility that we've created. There's a single source of truth for all of our data. It's stored in our store. The state can only be updated by our actions, and updates are made using our peer functions, or our reducers. And we've created a reducer. We've created a store that maintains the state. We can get the state using getState. And we've created some actions. So let's go ahead and take a short break. And then when we come back, we can add Redux to our actual application. All right, hello and welcome back. Before the break, we actually implemented our own small, simple Redux. And now let's actually start moving from our simple Redux to the actual Redux implementation. Our Redux implementation already has a pretty similar API. What we're missing is just a way to notify that the state is updated. And so let's actually install Redux and start to convert what we have into actual Redux. So one good place to start would be to npm install Redux. And so as we talked about in previous lectures, npm install will install some npm package and add it automatically to our package.json file. And so if we now look at our package.json, we see that Redux has been added down here. So let's now go ahead and start moving what we have into actual Redux. So I just copied exactly what we had from our simple implementation into this new directory called Redux. And here we're going to start actually using Redux. And so first thing we need to do is add this thing called create reducer, or create store rather. So if we import create store from Redux, now we have Redux's implementation of a store. And so previously we had our class store, which took a reducer and maybe some initial state and implemented all of the things that we thought we needed ourselves. But now we're actually going to use this function called create store from Redux. And so now we can actually just delete that implementation ourselves. And so now when we do new store down here, now instead of doing new store, we'll just invoke that thing called create store from Redux. And since I read that documentation, I know that it takes a reducer and some default state. And then we can dispatch some actions. And other than that, I think that's it. So that one line change there actually took us from our simple implementation of Redux to our implementation of Redux, to actual implementation of Redux. Unfortunately, if we want to run this in Node, it doesn't support that import statement. So I'm just going to do this real quick, which does effectively the same thing, just so that we can test it. So let's run this. And what do you know? We got back exactly what we had before. So it turns out the simple implementation of Redux that we actually wrote is pretty much adheres to the same API that Redux itself has. And so it didn't really take much for us to move from our simple implementation to actual Redux. Redux actually also gives us a few other goodies. So right now, the way that we we create a reducer that dispatches or that passes actions on to the relevant reducers is by combining them using a function that we defined here. But it turns out Redux also gives us a function called combine reducers, which does effectively the same thing for us. Rather than us writing a function that combines the reducers, we can actually invoke this thing called create reducer, or combine reducers from Redux. That just takes an object that maps the key in the actual store with the reducer that controls that key. And so we could do user gets user reducer, and contacts gets contact reducer. And now we've basically taken a little bit more complexity out of our application and maintain the same functionality. So again, if we test this, we don't have the initial state. So one difference here is that, did we not pass the initial state in? Let's actually add just a safeguard real quick that if this is null or empty, we'll go ahead and just create a default state for each individual reducer. So for the user, let's have an empty object, and for the contacts, let's have an empty array like that. And now run it. Now we get back exactly what we had before as expected. The one minor difference is that rather than having a default state app-wide, we can actually just define the default state in the reducers themselves. And so the default state for the contacts in our contact reducer is just an empty array. And the default state for our user, if the user reducer is invoked with no current state, we'll go ahead and initialize it to some empty object. And so now that's even more complexity gone. That just goes into the Redux library rather than our own implementation in this file. Great. So now we have a working store. It's just a lot of stuff in a single file. There's no reason that our store.js file should have our store, but also our action creators, also our reducers, and also all of our actions. And so let's start to split those out into separate files so that they're easier to maintain and find. So let's copy the store into this thing called reducer.js, and also copy the store into this thing called actions.js. So in reducer, actually let's do actions first. In actions, what do we care about in actions? We really only care about our action types and our action creators. Combine reducers, the things about stores, we really don't care about at all. So we can just delete that. We don't care about that. We don't care about any of these reducers. But we do, however, care about the action creators. And so now in our file called actions.js, we define the things that have to do with our actions. So there are our action types and our action creators. Some people prefer to have action types and action creators in separate files. But since we only have 2 of each, let's just keep them in this file called actions.js for now. And let's go ahead and export them. So now in our actions.js file, we are just exporting the available action types. And we're also exporting the available action creators. And that's all that this file called actions cares about. Now let's move on to reducer. So does the reducer care about combine reducers and create store? Well, half of it cares about combine reducers, but not create store. And this actually moved back to our ES6 import syntax. Do we care about action types? Yes, we do, because the reducer is checking against action types. But there's no reason that we should define them in this file. We should actually just import them from our file called actions. And now we can go ahead and delete the lines here. And so now what we have in this file is basically only the things that we need to define our reducers. And so we need this helper function called merge, which takes a couple objects and merges them together. We define our default state here, though we don't really need to. And then we have 2 separate reducers for 2 parts of our application. So for the part of our application that cares about contacts, we have this reducer, which takes state, which is initialized to an empty array, so just an empty list of contacts. We take an action, and we match against the action to see what we should do. We have the reducer for users here. So we say, give me a starting state for our users. If there's no previous state, just initialize it to an empty object. And give me an action. And we'll go ahead and match against the action type to see what we should do. And then we have our actual reducer that we're going to pass to our store, which just combines those two reducers. So just to stay maintainable and scalable, what we're doing is rather than having one reducer check against all action types and maintain the entire state, we have separate reducers for the part of the state that cares about user and the part of the state that cares about contacts. And if we want to scale up to the point where our user is starting to be an object that is unmaintainable by a single reducer, what we can do is we can create one reducer for half of that user, and maybe another reducer for another half, or maybe a third reducer for a third key in there, and go ahead and do something here where it's like combine reducers, and maybe we have something like something that cares about the user's metadata. That's called user meta reducer, and maybe we have something that cares about the user's logins. And so every time they have a login, we'll go ahead and add that to this part of the user state. And so maybe that is the user login reducer. And I'm just making up examples that are somewhat arbitrary, but I'm just trying to show that as our application scales up and as our application state gets larger and larger, what we can do is we can still take bite-sized pieces of that state and manage them by one smaller reducer. And we can compose these reducers into just one massive reducer that can take care of the entire state. And so this combined reducer, what it does is it allows us to split up one object into a bunch of separate object keys that are maintained by a separate reducer. And so since our application is pretty simple right now, we can do that all in one. But if we want to scale up, it is possible to start nesting reducers like that. Great. So let's actually export default this reducer, because that's the only thing that we want to expose from this file. We don't ever want somebody to use contact reducer or user reducer alone. We just want them to interface with that through this big reducer that we have at the end. And if it's easier for you to follow like this, we can define this variable called reducer and export default at the end, which is exactly the same as what we did before, but now we have a handy variable name to let us know exactly what this combined reducers is. Great, so that's the reducer. And now, lastly, let's clean out this store file. So we no longer care about that combined reducers function. Now we only care about create store. Do we care about action types in our store file? No, we don't. So let me delete that. Do we care about merge and those two reducers? No, we don't. We can delete that. Do we care about our main reducer? Yes, we do, but not in the context of this file. We can just import it from our other file. And so rather than implementing it here, we can just import reducer from that file and delete the declaration here. Do we care about action creators? Not in this file. Do we care about store? Yes, we do. So let's have const store be this thing that creates the store from the reducer. And we don't really need the default state since we declared it in each one of the reducers themselves. So the default state is basically this, where an empty contacts key just becomes an empty array, and an empty user becomes an empty object. And so we're still dispatching a bunch of actions. Let's comment those out for now. And export this store. Great, so now everything is in its own separate file. Everything's very readable. I believe every single file can basically be read without scrolling, which is, oh, I lied, but very close to that, which is pretty impressive since we're only showing fewer than 20 lines at a time. So it's very easy to now navigate through our application and know exactly where we need to update something if we need to do so. So if we need to add a new action, where are we going to do that? Well, in our actions file, we can add any action types up here and any action creators down here. If we want to change any logic in our reducer, we know exactly where that is. It's right here. If we want to change how we handle contacts, we can do that here. If we want to do so for users, we can do that here. And I immediately see a way that we can make this more readable. Right now, what we're doing is doing if action.type is update user, do this. If action.type is this, do this. If action.type is this, do this. So we keep matching against this string called action.type. There's actually something built into JavaScript that allows us to more easily match against a single string, and that's the switch statement. So we could do switch based on action.type here. And if you're new to the syntax, basically what it does is it allows us to check a particular variable and match it against a bunch of different possible values. And so if the action.type, if it's the case where it's update user, then we're going to do something, and that something is to do this. If it's update contact, instead we're going to do this. Otherwise, just return the old state. And now it's a lot easier to read. So there's no longer a bunch of if statements. We just know that what we care about is action.type. And if the case is it's an update user, then we return this. If the case is it's update contact, we return this. And if it doesn't match any of those things, by default, we should just return the original state. And then again, we combine the reducers and export it at the end. And then we import it into our file in store.js, which just creates a store out of that reducer and exports it. So again, we didn't really change any of the logic there. We just split things into smaller bite-sized pieces. And so a lot of a recurring theme that we see in this class is take a big problem and split it into smaller pieces that are bite-sized and maybe easier to digest. And so we went ahead and did that with our store here. And so now let's talk about it in the context of React. And so far, we've only really talked about Redux as a standalone library that tracks some data. But what we really care about is updating that, having that data update some views. And so we want to respond to, or react to, rather, changes in data in our application or our UI. And so now we have a few questions to answer. How do we get the info from our store into our components? Because right now, we've been using our store as just a standalone module and accessing at effectively the command line. But now how do you get this to run in an application? Well, it turns out our store has a handy method for getting that info. It's called store.getState. And so in our application, what we can do is we can actually access our state from our store directly. So we can do store.getState to receive that. And so now let's start integrating Redux into our application. So we already have this thing called store. Let's uncomment our mode of adding contacts. And so right now, I can't run this at the command line because we're using this import syntax. But our application state should be some contacts where the 3 contacts are myself twice and David once. And now we can go ahead and read from our store in our React application. So if you remember what our application looks like, is we just have a bunch of contacts. And these contacts can be toggleable, but they really just show on this simple list page. And so to dive back into the code from the past few lectures, where do we actually get those contacts? Is it in the contact list file? No, everything is in our app.js file. We have, right now we're just implementing our contacts from our random contact generator file that we wrote a few weeks ago. But ultimately, we're setting state in our application class and passing that through our navigation via screen props, and then accessing it in our relevant page by doing like this.props.navigator.getParam.whatever. And so it's a lot of work just to get our single key there. But there's actually more to that. We're also passing our contacts to every single other page in our application, even the ones that don't care about it. And so now what's nice about Redux is we can only listen to that information in the pages that we actively care about the information. And so we don't really care about contacts in all of our pages, right? We only care about it in the page that displays them. And so let's delete this code that passes the contacts as a screen prop to every single page. So if you remember back a few weeks ago, Brent was saying that there's a better way than passing screen props to every page. And he used that word Redux, which we didn't know what that meant a few weeks ago. But now we do. Now there's actually a way where we can say, oh, this information is only relevant to this particular component. And so now in that particular component, we can just have it listen directly to the state without it having to pass that state to every single component. And again, how are we going to get that information from the store to our components? Well, we can use store.getState. And so let's do that. So our screen called contact list screen is where we're getting that information. Right now, what we're doing is we're doing this.props.screenProps.contacts. And so let's actually do something different. So rather than looking at our screen props, let's do import store from Redux/store. So now that's our store. How do we get our information? Well, we can just do const contacts is store.getState, which is how we get the state from our store, .contacts. Because getState returns the entire state of our application. And if you remember, what that looks like is user with some user information and contacts with our list of contacts. We only care about the .contacts part. And so we can grab that and just pass that directly to here. And so now, hopefully, so add contact. Oh, because I uncommented something without importing what it needed. So let's just go back to Redux. So I ended up using add contact here without importing it. And so if I wanted to use that add contact action creator, I need to first import add contact from our actions file. And so now we can see that we're creating our people are showing up. However, their phone numbers are not. Let's see why that's happening. So we're creating people with name and numbers, and I assume that row is actually looking at a different. I think it's looking for a prop called phone. So let's actually just change number to phone. And so now we should be getting those phone numbers. So basically, we had a bug where I thought contacts were name and number, but we actually defined a contact to be name and phone. And so by storing the correct data, we then get it back in our application here. Cool, so this is awesome because if you ignore the keys that we didn't add, now we're getting that data in only the list that cares about it. So the separate screens that don't care about the contacts don't get access to our contacts. The scope of that information is limited only to the component that cares about it, which is a good thing. So now, how are we going to update that store? So if you remember back to the drawing of Redux, what's the only way to update the store? Well, it's by dispatching an action. And how do we dispatch an action? Well, we do it from a view, and so we can go ahead and add that action to our view. So we need to use store.dispatch in order to send that action to our store. We need to do store.dispatch in order to send that information to our store, and so let's actually do that. So in our previous iteration of the app, so if we do earlier, what we were doing is we were passing this function called addContact to every single one of our screens via this thing called screen props. But now we can do better by only passing the addContact function to the screen that cares about it. And what screen is that? Well, it's the one called addContact screen. And if you remember right now, the way that we're handling the submit is by doing this .props.screenProps.addContact, and then we pass form state. But we have a better way to do that now. We can actually just directly dispatch an action. And so let's do that. So first, we need to import store from our store. And we also need our action that we care about. So let's import addContact from Redux actions. And so now what do we want to do for handle submit? So rather than this, we can actually just do store.dispatch. And what are we dispatching? Well, it's the same thing that we were dispatching before. It's an action called addContact, or action creator, I should say, called addContact. And what is our action? Well, it's just our form state. And that's it. Actually, our form state has more information than we care about. So if we really want to be succinct, we could say the name is formState.name. And our phone is formState.phone. And now, presumably, we did what we wanted to. So let's go and check. We can add a new contact. Let's add Yowan Y and give a phone number. What do you know? He has the same phone number as I do. And submit. Oh, wait a second. Yowan didn't show up. Huh. But if we toggle contacts and reappear, look, there. Oh, I spelled his name wrong. But there's what should be Yowan. So why didn't he show up the first time? So there's one thing that we're missing as we've added Redux to our app, and it's that we're not getting the application to update when the store changes. And this is a bug that we've seen before, but this time it's different. And so how might we get our application to automatically re-render every single time our store changes? Well, presumably, we would want to use the other part of Redux that calls a callback every single time it adds, which is a lot of extra work for us. I wonder if there's a way that we could do that better. So we've talked about this thing in a few lectures before, this thing called a hawk, or in other words, a higher order component. And what a higher order component is it takes a component as an argument, or it returns a component as a result of a function. And so we could actually create a hawk that does a lot of what we've just done manually for us. What if we created a hawk that does the following? It checks for state updates automatically, or it subscribes to them, and then it passes new props when that happens. And wouldn't it be also cool if rather than having to go bind our action creators ourselves like we did here, or here, this line, what if we instead did that automatically? What if our hawk for us automatically bound our action creators to our dispatch function for us? That would be really cool. Then we wouldn't need to subscribe to store updates. Our higher order component can do that for us. And when I say our higher order component, I mean the one that React conveniently implemented for us. And so if we check this thing called React Redux, we see some official React bindings for Redux, which gives us a few cool things, and by a few I mean two. We have this thing called a provider and this thing called connect. And if we look at what this is, a provider, it basically handles the binding for us. It listens to a store, and it'll see when it updates. And then this thing called connect is a higher order component. So it takes a component as an argument, would actually takes some configuration as an argument, returns a function that's now expecting a component as an argument. We'll see exactly what that means in a second. But basically, it does a lot of things for us. It passes only the relevant props that we care about. So this function, the first argument we pass it is this thing called map state to props, which is actually a function that takes our entire application state and will return an object of props that we care about. Meaning this, for this particular component, it doesn't care about our entire application state. It only cares about a subset of it. And for a particular example, our contact list screen doesn't care about our entire state of our component. We only care about this one key called contacts. And so it would be great if we had a higher order function which handles this for us. It listens to the store, it grabs the state, and it only passes contacts down. And the way it does it is a prop. And so this connect function implements that behavior for us. We pass it a function that maps our application state to only the props that we care about, and then it passes those down as props for us. And so let's go ahead and first install this library so that we can use it. So npm install React Redux. And as you remember, this will also add it to our package.json. So if I look at our package.json, I can see React Redux got added. And now we can go ahead and use that connect function. So in our contact list screen, rather than importing the store itself, let's actually only import connect. So we now have access to this higher order component called connect, which we can now use. So rather than default exporting this entire class, let's actually wrap it in a higher order component. So let's down here do export default connect. We're going to pass it something, and then we're going to pass it the class that we created. So this thing called contact list screen. And what do we pass it? Well, we pass it a function that maps our application state to our props. And so we can do const map state to props. I can really call this whatever I want. Let's have it take our entire application state and only return the subset that we care about, or in other words, the contacts. And so a prop called contacts will get mapped to state.contacts. And then, of course, pass that function into connect. So again, the first argument to connect is just a function, which I happen to call map state to props. We can call it whatever we want. We can call it get state or props from state. But I'll just follow convention and call it map state to props, which takes the entire application state and returns a subset that we care about, or in other words, the prop contacts, which maps to state.contacts. And then in here, we no longer have to do that. Now we just do this.props.contacts. Because what this higher order function does is it listens to our application state. It will automatically update as the state updates, and it will pass down some number of props. And the props are just contacts for now. And what is contacts? Well, it's whatever the state value of contacts is. And so that is done. Unfortunately, it doesn't quite work because it doesn't know what our store is. And so now we also have to use the other part of React Redux and let our application know what our store is. And that is through that component called provider. So if we import provider from React Redux, what that does is it provides our app with a concept of what our Redux store is. So we can just wrap our entire application in this provider and let it know what our store is. And this component will provide any of its children with our store. And so our store, we should just import from Redux, or the Redux implementation that we wrote. And now the store is passed to any of the connect functions that we have. And the connect function, which we wrote in contact list screen, it can now listen to the store and map any changes in the application state to props that it passes to this contact list screen, which we then listen to fill our list. And so now we see that it's been sent here, which is cool. Lastly, real quick, what it also does is we can automatically bind our action creators to dispatch. And so a quick example of that is in our add contact screen. Currently, we're not doing any binding at all. We're just passing add contact, the return value of that, straight to store.dispatch. And it turns out rather than doing that manually, we can just import connect from React Redux, and rather than default exporting this entire class, we can just export a wrapped version of this. So we'll connect some configuration, and then pass it our add contact screen. And connect takes a couple arguments. The first one is map state to props. Our add contact screen doesn't care about any of our application state, so let's just pass some null value there. But it does care about our actions. And we can pass an object into our second argument here, and it will automatically bind our action creators with dispatch. And so if I did something like add contact, so we're going to get a prop called add contact. What's its value going to be? Well, it's going to be add contact, which is the function that we imported from our Redux actions. And then it'll actually just pass as a prop to our function, to our component. So we can do this.props.addContact, which will automatically dispatch that for us, because it gets automatically bound by connect. And if you want to read more about how that happens, the documentation is linked in the slide. And now, just to ensure this works, we can go ahead and add Yoan Y here with a phone number like so, submit, and look at that. Our application automatically updated due to a update in our application state. So this was a quick example of how we use Redux in React. And next week, we'll dive even farther into Redux and show how we handle stuff like asynchronous actions once we do some data fetching. So thanks, and I'll see you next week.